Okay. Let me talk to you people first, and then what are the things which you have read in your numerical analysis in your first year course? You unmute yourself and tell that. Yes. Anybody? Yes. Unmute. Shivam Raj. Shivam Raj, are you there? Shivam Raj. Where is Mr. Shivam Raj?
Present, sir.
Shivam Raj.
Present, sir.
Show your video also. Show your video also. Let me see your
Yes.
face. Sure. You're not able to show your video?
Sir.
Good. So you are sleeping or you are sitting?
Sitting, sir.
Okay, it's good. Okay, fine. So what are the things that you have read in your numerical analysis in your first year? Do you remember that?
Sir, can you repeat?
What are the things which you have read in your numerical analysis in your first year? Numerical analysis part in your first.
So there was Newton's method, remember?
Sir, your mic is off.
Done that. Okay. Now you can hear.
Yes,
Now you
sir.
can hear.
Yes, sir.
Yes, sir.
I can trace who is doing that, so don't do that. You will be in trouble. Okay. So tell me, what are the things which you have read in your numerical analysis in your first year? Quickly tell.
LMVT.
Huh?
LMVT.
What is that?
Lagrange's mean value theorem.
Don't tell this abbreviated form. Okay. Then
Rolle's theorem.
this you have read in your numerical analysis. Lagrange mean value theorem.
No. So we read Newton's method.
Okay.
And like I only remember that.
Who is speaking? Who is speaking?
Sir, Arjo Rastogi.
Okay. Tell me.
Sir, I only remember Newton's method.
Newton's method and?
Sir, I only remember Newton's method. I don't remember the topics.
This is your which year? Huh?
Sir, second year.
Lagrange.
Then? Yes. Tell me.
Lagrange
Louder.
interpolation.
That girl was telling something. Who is she? Or shall I call by name?
Am I audible?
You
I
are.
was saying interpolation.
You should keep your mic closer to you yourself. Tell me.
Sir, I was saying interpolation.
Huh?
Interpolation.
And then?
Sir, and Newton-Raphson's method. And
Okay.
sir,
Newton-Raphson method. Then?
I think.
how to solve that
Bisection method.
system of, yes, tell me, bisection. No, that is,
Bisection method.
yeah, that is there. Okay, and any other method?
Gauss-Jacobi iteration, Gauss-Seidel iteration method.
Okay, good. So this Newton-Raphson method is for what? Newton-Raphson method is for what? What you do there? What you find in that?
For finding root of
Sir, for
equations.
approximations.
Which equations? Wait. No. Approximation you will do for any numerical analysis part. You will do the approximation.
Algebraic and transcendental equations.
Algebraic and transcendental equation. Only algebraic and transcendental?
The equations whose root cannot be found exactly. So we, using Newton-Raphson method, we find the root approximately near value we find.
Okay. Actually, in fact, for
With
any
actually with
Yeah.
each iteration we goes closer to the root of equation.
Is it guaranteed every time? Lot of questions comes. All these questions should have come in your mind. Is it guaranteed every time that you will get the next trade will be closer? Or
Yeah,
what is
yes.
No,
it is not
It's not
guaranteed
necessary.
because in this method it's
Yes. In this method, your voice is not.
less.
Your mobile was ringing.
Yes. Means the condition is that after every iteration, the difference between the answer should decrease. Means it should.
Now, does this depend on the initial guess? Have you ever drawn the graph of and then you have started with a initial guess and it diverges? Have you ever seen this? These are simple things you should have done on your paper. I mean, just take a piece of paper, do these things, whether it is going beyond if you know the, I mean, if you have a curve, you know that where is this root, where it crosses the x-axis, right? Girish.
Sir, actually there is some network problem. That's why I'm not able to hear.
No. You got a call rather than network problem. Don't tell the lie.
So that is only due to call. The network got disturbed.
So don't tell that. Don't tell lie. Everything we can trace it out from here. Okay. Rastogi.
Yes, sir.
Tell me. Newton-Raphson method is guaranteed to converge every time?
Sir, I think all over convergence is there, but not every time.
No. This is not the parliament election that you are giving the diplomatic answer. This is mathematics. Mathematics, either it happens or it doesn't happen. Very simple thing, right? So don't try to make these type of statement. Otherwise, once you go for the interview, you will face a lot of trouble. Okay, so you meaning by what? Meaning by that you people should revise your numerical analysis portion, whatever is taught to you in your Maths 1, Maths 2, everybody, right?
Okay, sir.
So this is the first thing you have to do. Okay, there is one more thing. Yes, tell me. Yes, any query? Yes, anybody? Okay, if there is no query, I will move further. Okay, there is one thing which I would like, because this time the classes are such that only one lecture each day. Numerical analysis of this solution of differential equations, it is a difficult one. That one lecture, if I start, I may not be able to finish even one part. So, is it possible to have class on Saturday, the 2 lectures continuous? I want an answer from you people. Rastogi?
Sir, I cannot tell on the behalf of the whole class.
No. You tell yourself. How can you tell? You are not the leader.
Yes, sir.
So you tell about yourself. Other I will ask continuously.
Sir, I think like there is no problem.
Others? Govind? Devesh Govind?
Sir, we might have NSS in the morning, but if it's kept in the afternoon hours, I don't think that I will have an issue with that. But there is a possibility that it will collide with the NCC and NSO.
Okay. And Sunday, do you have anything of that kind, Govind?
No, sir. On Sunday, we don't have extra academic activities.
Okay. So if it is not there, if it is comfortable to you people, so 2 lectures will during the working days, it is not possible to change your class. The only possibility is that either it is on Saturday or on Sunday, right? Adrija?
Sir, I really think that 2 days off on Saturday, Sundays, like it's useful because there are many assignments and many prof things that like we are free on Sunday, so they give assignment on that basis.
Oh, that you can do during the, the class is there Thursday, Wednesday, Thursday, Friday, right? So that you can do that period, what is there? It is just 2-hour matter.
So,
Tell me.
can you take it on Saturday evening around that?
Sir, evening we have NCC. Means I'm not sure, but we have NCC.
Okay.
So it's better to take it on Sunday.
So Saturday afternoon 2 to 4 would be fine for everyone.
Another person is
Saturday. Sir, NCC happens in the morning.
Sir, I think, sir,
No.
I think we should discuss it
starts at
properly. We will
One
tell
by
you after discuss.
Okay. So most of the people, 130 people are here, 130 plus 2 plus 2, 4 plus 5, 135. As 135 people are here. So what are the possibilities? At least we can discuss here.
Let the timetable for the NCC and SSS get released. After that, we can decide it. Because
no,
in
it
the
will be on
previous
Saturday.
in the
No,
previous
it will be on
sem,
Saturday.
our NCC class was like in the afternoon because of the classes.
Okay.
But this sem we are not having any classes on Saturday morning, so we can have NCC in the morning. But there are possibilities.
Okay. So can we have Sunday evening? That will be the better.
Sir, like right now it's mentioned at the time.
Yes, tell me.
So like 8 to 1 only they'll be giving. Like in the timetable, in the official timetable, it's given.
Your voice is breaking.
So
your voice is breaking.
Just a minute. Sir.
I don't think there's Sunday. Yes,
so Sunday would be difficult. Saturday afternoon should be better.
Yes, sir.
If you all agree, I don't have any trouble. Saturday afternoon. Anybody? Any objection? Any objection?
Yes, sir. Afternoon is good because in the afternoon we will not have any extra academic activities. Saturday.
Yeah,
also.
hopefully it should not be. Saturday afternoon.
Yes, sir.
Will that be 5 to 7 is all right?
Hello, sir. Am I audible?
Yes.
Yeah. So, like in the official timetable, it is mentioned 8 to 1 as the EA time. So, like NCC 8 to 1. Saturday 8 1 is EA time. So, NCC or NSS or NSO.
Saturday morning.
Yes,
Saturday
sir.
morning.
2 to 4.
Fine, I'm leaving that. I'm leaving that.
Yes, sir. 2 to 4 will be free for everyone.
Saturday. That will be. I mean, teaching during that period, if class is there, that's fine. But teaching during that period, some people will sleep, and so that is the trouble.
So otherwise, Saturday evening is also fine, sir. Maybe like
5 to 7. That's what I'm saying. 5 to 7. Saturday 5 to 7.
Yes, sir. That's right. That's no problem, sir.
5 to 7, you are not going to do anything. I know that. So that will be the appropriate time. Yes, Rastogi?
Yes, sir. I have no problem, sir.
Okay. Rahul Nath? Rahul Nath, are you there?
Yes, sir. No problem, sir.
And Govind?
Yes, sir.
What? Problem or no problem?
No problem, sir.
Okay. Avilas Sinha? Avilas Sinha?
Yes, sir. No problem, sir. It's fine.
No problem. So I'm asking one by one. Are you Siren?
No problem. No problem, sir.
Achha. So one by one, if you have no problem, you continuously start. Aditya Chawla?
Yes, sir.
Do you have any problem or not? You are listening
No,
or
sir,
you are doing something?
Yes, sir. I am listening, sir. I don't have any problem in the afternoon.
Okay. And then, good. Aditya Agrawal?
No problem, sir. But will this happen on every Saturday or just this Saturday?
No, every Saturday. Why this Saturday? I mean, 2-hour class, why one Saturday?
Okay, sir. No problem.
Achha. So I am asking Aditya.
Sir,
Next, Aditya. Tell me.
Hello, sir.
Tell me.
Sir, Aditya Jha, sir. Sir, I personally have no problem, but I have just one question. Like we have three 1-1 hour class in the whole week, and you are telling Saturday 2 hours. So in total,
No. That 2-hour one lecture and 1 hour because that cannot be converted to 2 hour, no?
Yes, sir. So
1
in
hour
total,
in 1 week lectures.
In 1 week we have 3 lectures in total mathematics, na?
Yes, right. Every week it cannot be less. It may be more, not less.
Okay, sir. Thank you.
So that's fine. Next, Aditya Rai. Your audio is not coming.
I don't have any problem.
Okay, Akash.
Sir, excuse me, sir.
Tell me.
Sir, can we shift the timing to 4 to 6? So we will be free after 6 to do our pre-work.
Yes, sir.
Yes. There's a
Yes, sir.
problem.
4 to 6 will be right.
4 to 6?
Yes, sir. 4 to 6.
Yes, sir.
Earlier than that.
Yes, sir.
So you one by one you tell that so that I can hear and I can understand.
4 to 6.
Aman, 4 to 6, Saturday 4 to 6.
Yes, sir. Yes, sir. It is okay.
Others, Amit Kumar.
Yes, sir. It is okay if 4 to 6.
No, it is 4 to 6. Once I have said means it is said. Okay, Anik Mandal.
Yes, sir, it's all right. It's all right, sir.
Ankam, sorry.
No problem, sir.
Ankit, Anurag.
Sir, 4 to 6 is also fine, but if it could be 3 to 5, then it would be better.
No, now it cannot be shifted like that. It is 4 to 6 now. So if it is all right, so you just tell that only. And otherwise, I will waste for the whole time here itself. So, okay, let me say this way. If anybody has, if everybody agrees, then shall we fix this Saturday 4 to 6?
Yes, sir.
Saturday?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
I
sir.
want more voice. I want more voice. One by
Yes,
one,
sir.
you tell.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes,
No,
sir.
sir.
Yes,
Good,
sir.
very
Yes,
good.
sir.
Not repeat. Don't repeat. Don't repeat. Okay. So, 2 class continuous will be on Saturday, and then 1 class. But don't fix any other class during the working days. Means Monday, Wednesday, and Wednesday, Thursday, Friday. Whatever the timing of my class is there, it will be the same one. You don't fix anything there. Is that clear?
Okay, sir.
Otherwise, there will be trouble. Because examination and other things are there. Lot of things are there. Not one thing is there. So, today now let me start the thing. You know the Taylor expansion.
Yes, sir.
One more thing. You just listen. You keep one register with you, one pen and calculator. These 3 things you must keep with you. Because I will tell you people that you do these things, and then there are certain people waiting. Why? So, Taylor expansion, you know, everybody. Yes? I want to answer.
Yes, sir.
Okay. So, you write down Taylor expansion of y in the bracket means as a function of x plus h. H is an increment. Everybody write the Taylor expansion of y of x plus h. H is increment. Quickly. Can anybody tell me what is the Taylor expansion? Anybody can tell me what is the Taylor expansion of yx plus h? Aditya Agrawal? Aditya Agrawal. If you don't respond, that will be
Yes,
counted.
sir.
Yes.
Yes, sir. Yes, sir.
Yes.
So
tell
the
me
Taylor
that.
expansion will be x minus h to the power n sigma of
What is
sigma
that?
from
What is that? X minus h to power n. You expand it. Don't write in summation.
Okay, sir. Like, wait a second.
Others, Adrija?
So it will be y of x plus y dash x into h plus y double dash x by 2 factorial into h square and so on.
Mr. Singh?
Yes.
Tell me that again. Y x plus h equal to?
Y of x
plus
y dash x into h.
H into y prime x. Yes. Then?
Plus y double prime into h square by 2.
H square by 2 factorial y double prime x plus 4 up to 4 derivative.
Plus y triple prime into h cube by 3 factorial.
H cube by first you write h cube by 3 factorial. First you write the increment part and then y triple prime x. At 4th you truncate it. So what will be the thing? H to power 4 by 4 factorial y 4 derivative at what point?
X.
No, you have to truncate it here.
So it would be x plus c of h, where c lies between 0 to 1.
Okay, so I am writing xi1. I am writing xi1, where xi1 lies between
X and X plus H.
X and strictly between X and X plus H, right? So it is some variable between that, some number between number between X and X plus H. You don't know what is that number, right? Similarly, you write down the Taylor expansion of Yx minus H. Adrija, now you tell me quickly. Adrija. Yes, tell me. Tell me the Taylor expansion of Yx minus H. Okay. Your voice is not coming. Okay, anybody else?
Sir, should I?
Sure.
Sir, y of x minus h y dash x by 1 factorial plus y double dash h square by 2 factorial minus y triple dash h cube by 3 factorial plus.
You have to truncate again at that fourth derivative.
Plus h to the power 4 by 4 factorial y 4 times dash 4 derivative at x at
some another. So let us write some another point xi2, where xi2 lies strictly between your x minus h2
h and h.
X minus h to x,
yes.
Not h, right? Acha, you do one thing. You add these two expansions. Means you have to write down what is yx plus h plus yx minus h. Odd gets cancelled out. So it is 2yx. Tell me, 2yx.
2 times yx plus y double dash x h square by
h
2
square y double dash
by 2 factorial plus y quarter dash x y quarter dash 4 derivative xi1 plus y4 derivative
4 factorial and then the addition of the 2, right?
Yes, sir.
Okay. Now, normally what we do, we take h very, very small. Normally, we take h very, very small for any work. If you have seen that, right? Now, so if h is very, very small, we can use the mean value theorem. We may say that xi1 and xi2 will lie between x minus h to x plus h. I have taken the combined one. Xi1 and xi2. So let us take, can you take a single xi if h is very, very small? Hello? Anybody? Gobind?
So, but one will be more than x and one will be less than x. So I don't think so we can take it. I'm not sure, sir.
That's the reason I have taken. If h is very, very small, tending to 0, then those 2 points can be considered as very close to each other, right? So in that case, x we can take a general point xi using the mean value theorem, which lies between x minus h to x plus h, right? So this we may write that combinedly, instead of s to power 4 by 4 factorial, 4 derivative of y at xi1 plus 4 derivative of y at xi2, we write 2 times s to power 4 by 4 factorial and then 4 derivative of y at the point xi, right?
Yes, sir.
Yes. Now we write this. Now rewrite it. Y double prime x equals yx plus h plus yx minus h divided by, or minus yx, or minus 2yx, you write that also, minus 2yx divided by h square plus 2h to power 4 by 4 factorial, sorry, 2h square by 2h square by 4 factorial, 2h square divided by 4 factorial y 4 derivative xi. Can we write this? I have just rewritten.
Sir, can you repeat?
Yes, sir.
I have just written y double prime divided by h square. I have taken y double prime one side and remaining on the other side. So it will be y double prime equals, I am repeating, yx plus h plus yx minus h minus 2yx whole divided by h square plus 2h square divided by 4 factorial, 4 derivative of y at the point xi. Is that right, Govind?
Sir, what was the last?
Sir, someone has muted you.
Shall I trace that person? You want that I should stop the class and trace that person and send the message to the dean? If you want, then I should do that, and then that fellow will be deregistered from this course, maybe deregistered from the institute, expelled from the institute. If you want that, I will do that. I have to just tell the MS team people, they will immediately trace out the person with their place and everything. All the things will be traced out. So this is the second warning. Third warning I will not give. It will be sent to the dean. Okay. So now, if we write y double prime x approximately equal to, or let me write y double prime x, and we ignore this portion, the last portion, that is 2h. Yes.
So can you please share those things in which you are writing?
No, you have to do first. Sharing part will be the another one.
Sir, we can't go with you.
Yeah, sir, it is somewhat difficult to keep up with you.
I will share the whole notes. Don't worry.
Because sir, it's not possible to keep track of everything.
It is done as last time. No. What I have said. Iron?
Yes, sir.
What I have said first. I have said that you write down the Taylor expansion. You have to do it there. Write down the Taylor expansion of yx plus h. Don't unmute yourself. Unmute yourself.
Yes, sir. I wrote like Taylor expansion of x plus h and x minus h, y of x plus h, and after that you told to add them. And after that.
So what you got?
So 2 times of y of x plus y of x into h square by 2 factorial plus y of h ki power 4 by 4 factorial.
y4 xi. Again you are you have muted yourself.
Yes, sir.
So you rewrite y double prime will be what? Y double prime will be yx plus h plus yx minus h minus 2yx divided by h square plus. Is that clear?
Yes, sir.
Plus 2h square by 4 factorial, 4 derivative at the point xi. 4 derivative of y at the point xi. Is that clear?
Yes, sir.
Okay. So okay, let me take a even simpler one. before I go for the simpler one, let me ask one thing. Why you study numerical?
Excuse me, sir.
Tell me.
Excuse me, sir. Sir, actually, the problem is that not everyone has a stable internet connection. So when you speak, the words, the voice cracks. So we cannot cop up with it. So it's like add X blank space and solve the following. It's something like that we hear.
Okay. No.
It's
Everything
very
will
hard
be
to
shared.
decode it.
Harshal,
Sir,
just wait.
what I want is like, sir, if you can share it while doing these things, then it would be very beneficial for us. Like we can.
No. There is a reason why I am doing that. I can share it. It will be shared. It will be shared immediately after that. I'm just trying to explain the whole thing first. Okay, let me ask. Okay, forget about this. Let me ask the very simple thing. Why you study numerical? Why you apply the numerical methods to any problem?
So basically, computers do the problems using the numerical methods only.
Not at all. You are going beyond that. Yes. Anybody else?
So because it is hard to find the exact solution, so we use numerical analysis to find the approximate solutions of these problems.
Yes. I understand that Now you are saying that if it is not possible to find the exact solution, then we go for the numerical solution. This is what you are saying, Govind?
Yes, sir. An approximate solution.
Okay, an approximate solution. Okay. Now, let us see very simple problem. You have seen the first order problem, y prime equal to fx. Up to fx, I think you have seen. I am writing y prime equal to fxy. Y prime equal to fxy. Write down that on your notebook. Y prime equal to fxy. Have you written?
Yes.
Everybody has written? Okay. No, before I proceed, there is certain things which you have to understand. So this fxy is a non-linear function. This fxy is a non-linear function. What is the meaning of this? Non-linear in y. You know the linear curve? How will you write the line equation of line?
Y is equal to mx plus c.
Y equal to mx. Power of x is
1.
So it is a linear function. That's the reason you call it linear, right? Now, if power of x is not 1, then you say it is a non-linear in x. Yes or no?
Yes, sir.
Yes, sir.
So here this fxy is non-linear in y. So we write down that this we write as hx, a function of x, plus gx. If we write this gx into y, hx plus gx into y, so this will be a linear function in y. This will be a linear function in y. If the power of y is not 1, then we say it's a non-linear function of y. So if fxy can be written as hx plus gxy, then we say that fxy is a linear function in y. Otherwise, we say that it is a non-linear function of non-linear function in y. So in that case, this y prime equal to fxy will be your non-linear differential equation. Will be a non-linear differential equation. Now, if you want to find out the solution of this y prime equal to fxy with a given initial point, ya equal to, let us say, y naught, and since it's a non-linear differential equation, you cannot find out its solution, exact solution for any general non-linear differential equations. So what will you do? There is a domain. Let us say domain is your a to b, the interval, because it is x belongs to that. So domain is from a to b. You have to subdivide this interval a to b in subintervals. So let us write the division as the uniform division. write the division as uniform division. Uniform division. So let us take that n number of subdivisions are there. Are you able to see some 5?
Yes, sir.
Yes, sir.
Yes, sir.
So you have to wait for that. Everything cannot be just. Right. So this interval is there A to B, right? It is visible to everybody. Is it visible to everybody? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Good. Good.
Yes, sir.
So at least those who are having the net problem, whether it is visible to them.
Yes, sir.
Yes, sir.
Yes, sir.
Good. 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 So you see, I have written that x naught equal to a less than x1 less than x2 and so on less than xn equal to b. So you have a subdivision of the interval a to b. So a is your x naught, next point is your x1, next point is your x2. Similarly, the last point is your xn, that is your b, right? If this is uniform, it is written for non-uniform mesh spacing. If it is uniform, so what will be the step size? H will be, what will be the step size? Anybody? What will be the step size?
A minus B by N.
Not A minus B, it will be B minus A.
B minus A by N, sorry.
B minus A by, let us say the capital N I am using for, here it is small n is written, okay, let it be small n. So B minus A by N, so means what? X1 will be written as, X1 will be written as A plus H. X2 will be written as, either you write A plus or X1 plus H, or you write A plus 2H. Similarly, your xk can be written as A plus kh, where k is some integer number. Is that clear? Is that clear to everybody?
Yes, sir.
Yes, sir.
Okay, so why we are doing this? We cannot find the continuous solution, the analytical solution. We cannot find that. So what we'll do, we'll try to approximate the solution of the differential equation y prime equal to fxy at these discrete points x1, x2, x3 and so on up to xn. Is that right? Is that clear to everybody?
Yes, sir.
Yes, sir.
Okay. So this is the first point. The another thing is that your differential equation y prime equal to fx, y prime equal, you write on your register y prime equal to fxy. This is given to you with your ya equal to y naught, the initial guess, initial value. So this is a initial value problem. This is called initial value. This must have been told to you in your maths 1, maths 2. Yes or no?
Yes, sir.
Yes, sir.
How many points do you require for the first order differential? How many conditions do you require for the first order differential equation? Y prime equal to fx to get the exact solution rather than the general solution. How many conditions required?
1.
1. For second order?
2.
Right. So this way, if you have the nth order differential equation, you require n conditions to be get the particular solution of that problem. Is that clear? Is that clear?
Yes, sir.
Okay. I'm giving a very simple. You have already written the Taylor expansion of yx plus h. You have already written the Taylor expansion of yx plus h, right? So since this differential equation, this interval is divided into n subdivisions, and at each point, a general point, let us say xk, this differential equation is satisfied. Means yk prime equal to f of xk yk. I will show that. I will show this part also. Don't worry. So y prime xk equals f of xk and y of xk. Is that clear? Is that clear?
Yes,
Is that clear? Huh? Is that clear?
Sir, can you explain once again?
Okay, that is the basic trouble. You people have given very spoon feeding. That's the reason you are not able to. So I am showing that now. You see, it is written y prime equal to fxk. Is it visible on your screen?
Yes, sir.
Yes. Okay. Now, so this differential equation is valid at any general point. You have already subdivided that interval into n number of subdivisions. Xk is a general point. I have already told all those things. You have already seen the slide also. In the beginning it is shown. You see that the interval a to b is subdivided into x1, x0, x1, xn, x2, and general you may write xk and then xn. Is that clear?
Yes, sir.
Okay. So differential equation is valid for whole domain.
Yes, sir.
So it is valid for the general point in between xk.
Yes, sir.
Write down y prime xk equal to f of xk, comma y of xk. Everybody should write down. Have you written?
Yes, sir.
What is xk?
It is a point between A and B.
No, that's fine. So rather I will take xk plus 1. That will give a better one. So write down xk plus 1. So y prime xk plus 1 equal to f of xk plus 1 and then y of xk plus 1. So xk plus 1 will write as xk plus h. Is that right? Yxk plus 1 equal to yxk plus h. Hello?
Yes, sir.
Yes. I want answer from other people also. I want answer from other people also. Bhanu Singh? Bandhu Singh?
Yes, sir.
Bandhu Singh, Sneha Bandhu Singh?
Yes, sir.
Yes. Hello?
Yes, sir.
You speak only, then I can understand.
Hello. Am I audible, sir? Hello.
Tell me. Do you understand what I have said?
Yes, sir. Xk plus 1, we have replaced it by xk plus h.
Xk plus h. So what is the expansion of your yxk plus h? You have already written. Earlier it is yx plus h into y prime xk, y prime x. Yes or not?
Yes, sir.
Yes. Okay. So let me use some notation. I think it is you write down the notations. Y xk as, write down the notation y xk as yk, y suffix k, and f of xk, y of xk we write as f of k. Have we written that?
Yes,
Have
sir.
we written that? Now, so yk plus 1, if you write the Taylor expansion of yk plus 1, what will be that? Yk plus 1 can be written as yk plus h times y prime k. If we just truncate at this point, just I am taking up to first derivative. If you take the error term, here it will be h square by 2 factorial y double prime xi, where xi will lie between x 2x plus h. Is that clear, the Taylor expansion? Whether the Taylor expansion is clear?
Yes, sir.
Yes. Okay. Now, you replace y prime by f. So yk plus 1 will be your yk. Leave that error term, the last term, leave that, h square by 2 factorial y double prime. So it will be yk plus h fk, y prime here it is. Is that right? Now I can
Yes,
show
sir.
that slide. Now I can show that slide. You see, I have written here yj plus 1 equal to yj plus, is it visible to everybody?
Yes, sir.
Yes. H yj prime plus h square by 2 factorial y double prime xi. This is the error part, the remainder part, if you say. Right? Is that clear?
Yes, sir.
Yes,
sir.
Yes,
okay,
sir.
so yj plus 1 equal to yj. Y prime I am replacing by f because the differential equation is given as y prime equal to fxy. So this is replaced by f. If we leave this th, this error term, so what will be this? This will be your yj plus 1 equal to yj plus h times f of xj and then y at the point xj. In other words, in the notational form, we may write yj plus 1 equal to yj plus h times yj. Now, for j equal to 0, this will be what? y1 equal to y0 plus h times f of 0. F of 0 means f of x0 and then y0. Now, ya is given, ya or yx0 is given. This point is taken as y0. This value is given as y0. This is already given to you. So if y0 is given to you, you see that y1 will be y0, whatever the value is given, plus h into f of x0, y0. All the things are known on the right hand side. So you get the next value y1, that is the solution at the point x1. Next, once you have got y1, you can go for y2. So y2 will be your y1 plus h times f of 1 means f of x1. x1 is known and y1 is also known now at this stage. So on the right hand side, everything is known. So it is your y2 is also known. See, you are getting the solution at the discrete point y1 means at the x1, y2 at x2, and continue this process, you will get the values of, this is called your Euler method. This is called your Euler method, and it is just, you have taken the forward, I will tell that, what we call it. This is called the forward approximation. So, using this simple Taylor expansion, you have got a method which can solve your nonlinear problem y prime equal to fxy, which can solve your problem y prime equal to fxy. what will be the speed, means convergence rate and other things, that we'll talk later on. Now, there are certain things which is told to you here, which has to be explained again. The reason is that what we call that you have divided into subinterval. What is that called? What is the points? These discrete points are called, and so on and so forth. So that I will explain on next class. That is your Saturday. All the materials are uploaded. You can download from here. It is uploaded. I hope you can see that materials. Hello. Hello.
Yes, sir.
Yes, sir.
Can you see? Can you see that material on your MS Team?
Yes, sir.
Yes, sir.
So you download that, go through that, right? And then we'll take. I will take up the class on Saturday. That will be from 4 to 6. It will be 2-hour class. Yes.
Don't we have class tomorrow and on Friday?
No. So then, how many class do you want? I can take that. There is no trouble.
No, Saturday is fine.
Saturday 4 to 6, right? So 2 lectures there, 1 lecture from these weekdays. Rastogi, tell me.
Yes, sir. No problem.
Okay. Anybody has any problem?
No, sir. Not at all.
Okay.
So what about attendance?
What about?
Attendance policy.
You have come for attendance only? You have joined for only attendance? Hello?
No, sir, but I am asking it will be evaluated or not.
No. The point is that you want to learn, or you want to you are bothered about the attendance. You learn that.
Yes, sir.
Attendance is my problem. If you are there, your attendance will be counted immediately. Right? Is that clear or not?
Yes, sir. So can you tell us the marking scheme, assignments and tests?
You shall I tell the grade also? Yes. Who was talking? Shall I tell the Yadav?
Yes, sir, it's me.
So shall
Sir,
I tell
I'm just
the grade?
asking. No, sir.
No, I'm telling you first learn. These things doesn't come in the picture at this moment. This is the very first lecture and you are asking for all these things. Right?
Okay, sir. Thank you, sir.
So the thing is that the whole numerical analysis to differential equation, this course requires extensive use of Taylor extension and the numerical analysis which you have already read in your Maths 1, Maths 2. So revise that carefully, right? Notes and other things I will be uploading continuously. Don't worry about that. It will be available to you, and the video recording is also there. That will also be available for 20 days. You have already accustomed with that. Last semester, everything was done through that. Yes or no?
Yes, sir.
Then what is the trouble? Everything is